Week 12, Section 3, Swyk number 1, and the only Swyk of this particular assignment. So, I just had too much. I didn't want to throw it into the last one. I guess I could have, but oh well. So the Swyk and the assignment are pretty much the same, except the Swyk you get all kinds of chances. The assignment you only get one chance, as you know, unless I screwed something up. Now, what if we're dealing with non-right triangles that we don't have a known angle and a known opposite side? Can't use law of sines in that case. So we need a backup plan. We need something like called the law of cosines. Now, before you get all, crazy on me about, what the heck's that? Okay, let's take a look at this. Notice what's in the red here. Okay, hopefully you see that and go, oh, hey, that's the Pythagorean Theorem. A squared plus b squared equals c squared. That is true. The Pythagorean Theorem is actually a specific case of what we call the law of cosines. The law of cosines actually has this extra term added onto it, minus 2ab cosine c. Now, if you take your calculator and you type cosine of 90 degrees, what you're going to find out is you get 0. Well, what would that do to that last term in your formula? Boom, gone. Therefore, a right triangle, you don't see that part. Okay, I don't know if I can use any of my annotate writing tools to get all cool here, but yeah. Okay, so if you had a right triangle, that part disappears. Gone. Not there. Now, suppose we're in a non-right triangle. I should probably erase that box now. There we go. In a non-right triangle. So capital letters represent angles, lowercase letters represent sides. What I'm guaranteeing you when you use the law of cosines is that one of the ends of the equation is going to be your variable. It has to be. If it's not, guess what? You used the wrong formula. You should have been using the law of sines. Otherwise, you'll come up with a quadratic, and then you'll panic, and you'll be like, how do I do that? And then you would need the quadratic formula from last semester, and you get all kinds of nasty, ugly numbers. Let's not go down that road, folks. We want to use the law of cosines as a last resort. If you have a right triangle, don't use the law of cosines. Use SOHCAHTOA. If you've got a known angle and a known opposite side, use the law of sines. This is for when those two plans fail. This is your backup plan. Okay, now, when you're doing the Pythagorean Theorem, the most important decision you have when you're trying to figure out the sides of a right triangle is this over here, the hypotenuse. If you can figure out which one is called the hypotenuse, then the other two, doesn't matter whether you call 1a, 1b, or reverse them. Same thing happens in the law of cosines, except your most important decision is here and over here. What goes at the very ends of the equation is the most important. For instance, when I look at this triangle, I see 95 and x. Those are across from each other. One of them I know, one of them I don't. Guess what? That's the pair that's going to be at the end of the formula, which we will write here in a moment. But that's what I'm looking for. I'm looking for that kind of information to stick at the ends of the formula. Like I said, one of those has got to be your variable. So you can see here in this particular example that I put the x on the left, I put the 95 on the right, and then it doesn't matter whether all I need in here, I need a 2 and a 6 and a 2 and a 6. Doesn't matter if you switch them either. But you need one of each in the first part, one of each in the second part, and then this particular version of the law of cosines is pretty simple because you can just type all that stuff straight across and get 42.092. Of course, you're going to have to take the square root afterwards and get 6.487. Which then leads us to the nearest tenth. That's what they said, nearest tenth. Always make sure you understand how Math Excel wants you to round. In this case, 6.5. Check that work just to make sure you're doing it right on your calculator, but you should get that value. Question 2. Wow, same scenario. Probably not going to go through this with you, but you see the known angle and the known opposite side. 80 goes at one end, x goes at the other end. Type all that stuff in, take the square root, 22.5. So that's a pretty straightforward situation. The next situation is a little bit more complicated. It's not horrible, it's just more complicated than the last one. Suppose you have a missing angle. Whoa. What's going on here? There we go. Missing angle. You've got all three sides, but you're missing the angle. Still a law of cosines question because we do not have a known angle and a known opposite side. Now, before we get started on building this law of cosines question and seeing how it's different, I'm going to bring you back to your days of Algebra 1, maybe even pre-algebra. And I want to ask you how to solve this equation in green. I know it has nothing to do with this equation, but I'm trying to prove a point to you. Okay, so what would you do to solve this? I'm hoping that you would say, oh, Mr. Staley, you should take the 3 minus 7 and get negative 4. In other words, you're combining like terms. Hopefully you would do that, right? And then you would say, oh, Mr. Staley, I should add 4 to the other side. Get the constants together. I'm hoping you would say that. I'm hoping there is absolutely nothing in your being ever that would say, heck, those look like terms. I'll just add them together and get negative 6x. Don't do that, folks. That's illegal. And I know some of you are like, Mr. Staley, I would never do that. Not to you or anybody else. Doggone right you wouldn't. Now, the reason, I'm hoping that everybody knows that that is an illegal move. However, when we do this next law of cosines question, I see year after year after year people do that exact thing. And I know you're swearing to me right now you wouldn't do it, but people do. So let me show you what I mean. And of course, at the end, you have to, after you added 4, you would divide by negative 2. Okay, and I'm hoping that's exactly what you would do. So let's go to this particular question and look at it. So we've got the 15 goes on the left side, and on the other side is my x. Okay? Then I need a 14 and a 28, and a 14 and a 28. Remember, it doesn't matter what order you put them in. We do want to put the 14 squared and the 28 squared together, right? We want to add them together. And then what are we going to do to move that to the other side? We are going to subtract that to the other side. Okay? And then what would we do with this chunk of information? It is being multiplied times cosine x. Opposite of that would be to divide it to the other side. And then there's a third thing that needs to be done. We need to invert the cosine. So 3 steps. Subtract, divide, oops, off camera. I cannot get this straight. Subtract, divide, invert cosine. So it's a little more complicated. Now, I want you to look at the calculator instructions that I like to use on my calculator. Now, if it makes you feel better and you want to figure out what 14 squared plus 28 squared is and write that number down, then be my guest. Do it. But I don't really need that information. So look at what I'm doing. Okay? I'm telling my calculator right here, 15 squared minus the quantity, use parentheses, 14 squared plus 28 squared. When I do that, it spits out a number. Just hold that number in your calculator. The next thing I needed to do, we said, was divide this chunk of information. So when I hit the division key on my calculator, immediately ANS shows up. So it's going to take the answer, which whatever it is on your calculator, and it's going to divide. Notice how I use parentheses, and I put negative 2 times 14 times 28. And literally, I'm going to get another value. Okay? So then I take that particular value, and I go cosine inverse. Now, cosine inverse is right above the cosine button, right? Make sure you can find the ANS button on your calculator. Now, For some of you with a scientific calculator, specifically like a Texas Instruments version calculator, toward the bottom there should be a negative button. I mean, like on the bottom row, and right above that it'll usually be a second feature. You want to find the A and S button. Now Casios actually have a button called the A and S button, so you just push it. One of the only things that I like about a Casio versus the Texas Instrument versions. And if you have an older style calculator that does not print the values across the top of the screen, then kind of like the old style that I used to have when I was in high school, many ago. Hey, I'm coming up on 30-year high school reunion. I didn't even realize that. Yep, folks, it's true. Okay, so way back when I had a calculator and you had to, work through the scientific order of operations. It just didn't print things on screen like yours do today, which is kind of nice. If you have a graphing calculator like a Texas Instrument graphing calculator, that little negative at the bottom has the A and S above it also. All right, now, so 3 steps. Subtract, divide, invert cosine. It really goes pretty quickly, especially if you use the parentheses and let the calculator do the work for you. Okay, so my next example, pretty much the same thing. Now I wrote it out maybe a little bit longer, but or more algebraic-like. But you can see that I took the chunk that was right here and I subtracted it to the other side. That's what I have right here. And then I knew I was going to divide. So I divided that chunk on both sides, pushed it over here, and then of course I inverted the cosine. And both of these were rounding to the nearest tenth, so I got 15.6 on the first one, 42.7 on the second one. So subtract, divide, invert cosine. Piece of cake. All right, that's the end of this lesson, and you can move on to the assignment and then on to your test. Take advantage of the retake if you need it, and get some help from me if you need it. All right. Talk to you later. Have a great day.